Firstly, you will deal with temperature. If it is hot, temperature has a high value, and if it is cold, temperature has a low value. If you are measuring the temperature of a fluid, it will be high if the molecular activity is high, and low if the molecular activity is low. Temperatures can be measured on 4 different scales. Fahrenheit and Rankine are related, while Celsius and Kelvin are related. For example, an increase of 1 degree Celsius means an increase of 1 degree Kelvin. Relative temperature scales are used in everyday life. The 2 points correspond to well-known phenomena that people can relate to. For the centigrade scale, the freezing point of water was assigned a value of 0 degrees centigrade, while the boiling point of water was assigned a value of 100 degrees centigrade. Fahrenheit used to add salt to melting ice to lower its temperature. By immersing his bottle or glass in the mixture, he could chill his drink nicely. 0 degrees Fahrenheit was therefore assigned to the mixture, while the temperature of a human body was assigned a value of 96 degrees Fahrenheit. The following formula is used for the conversion. Note that, if the temperature is 0 degrees centigrade, 1.8 is multiplied by 0, and the degrees Fahrenheit is 32. Press pause and try this example yourself. The answer will be displayed when you press run again. "99 degrees Fahrenheit is the temperature of a human body, which is 37 degrees centigrade. The answer therefore makes sense. The minimum possible temperature in our universe was determined from the ideal gas law in thermodynamics, and is the temperature far out in outer space. As you saw before, temperature is the degree of hotness, determined by the energy of molecules. If the molecules are motionless and do not move, they have no energy, and the temperature is 0. In terms of degrees Fahrenheit and Celsius, you can see that the minimum temperature is very low. For example, 0 Kelvin will be at minus 273.15 degrees Celsius, hence there cannot be a negative temperature in kelvins. If you start at 0 degrees Kelvin, and increase the temperature by 10 degrees centigrade, you end up with a temperature of 10 degrees Kelvin. Again, from the formula, you can see that if you increase the temperature by 1 degree Fahrenheit, you increase the temperature in degrees Rankine by 1 as well. An interval can be an increase or a decrease. For example, the temperature increased by 100 degrees centigrade. The two meanings follow now. This is the boiling point of water, and the degrees Fahrenheit are calculated as before. This is if the temperature increases or decreases by 100 degrees centigrade. This means that the temperature increases or decreases by 180 degrees Fahrenheit. (32) is added to both initial and final temperatures in the conversion to Fahrenheit. The two temperatures are subtracted, so the 32s cancel out. Heat capacity in American engineering units is given as shown. Construct an equation for heat capacity in joules per mole per degrees Celsius. Press pause and try this yourself. I shall give you a hint when you press run again. Here is the hint: first convert degrees Rankine to Fahrenheit and then to Celsius. The answer will still be in the American units, so you then have to multiply by 3 conversion factors to get SI units. Press pause and try again. Pressing run again will display the answer. To get degrees Rankine, you need to multiply degrees Celsius by 1.8, and add 291.67. In this expression for heat capacity, temperature is entered in degrees centigrade, and then automatically converted to Fahrenheit. The answer obtained will still be in the American engineering units. The expression therefore needs to be multiplied by conversion units to convert to the SI units.